session we discuss about different types of operations that can be performed in Python. Say operations are basically performed on operands, right? Suppose I have an expression a plus b. Here a and b are the operands and plus is the operator. So the operations that can be performed depends upon the data type. So there are three types of operators mainly: unary, binary and tertiary. Unary operators takes only one operand. For example, tilde a. So it's nothing but negation of a or complement of a. So it is performed on only one operand. So that's a example of unary operator. Binary operators will have two operands, right? For example, a plus b. This is actually this is a binary operation, and plus here is a binary operator because it plus here is working on two operators a and b, but the output will be only one. Tertiary means you will have three operands here. For example, the operator is going to connect three operands here, so three operands would be taken as input. So the different you have this is a classification of operators: arithmetic operators, compound assignment operators, relational operators, logical operators, bitwise operators, identity operators and membership operators. So we will see all of them in today's session. So this is the first one, arithmetic operators. So arithmetic operators are plus, that is addition, subtraction, modulus, percentage is a modulus, and division. These are some of the arithmetic operators. You also have something called as double division, double slash like this. This performs the floor division. It means it returns only integer quotient after the division. So I will show all of these examples in the Jupyter notebook. And percentage, this is actually a modulus. It retains a remainder after the division. So the different types of arithmetic operations are addition, so x plus y. You have a subtraction, x minus y. Multiplication, if you want to do x star y. Then division, if you want to do x slash y. If you want to do exponential, then x raised to the power y. Integer division, if you want to do int of x comma y, so x divided by y. Suppose the division of x by y gives a value 12.3. If you say integer, it will only get 12. You also have floor division. That's nothing but floor division. Okay, and remainder is, if you want to take the remainder, you have to use a modulus sign. So just quickly go to the Jupyter notebook and perform all these operations. So let's give a print of, before that, let's say I want to say a is equal to 12 and b is equal to, let's say 5. So to perform addition, what you have to do is, let's copy paste this, all of this. Okay, so now let's do addition: a plus b, subtraction a minus b, multiplication is a star b, division is a divided by b, where you will get the quotient. And if you want to do floor division, then it is a double slash b. So basically what happens, if 12 by 5, the answer is actually 2.4. So instead of giving the answer of 2 by 4, here it will give the answer as 2. So that means it will take only the integer part, or it will neglect all the numbers after the decimal point in the quotient. If you want only the remainder, then you do a modulus b. Yes. So let's check all of this. See. The first one is a plus b, 17 is the addition, this is a subtracted value, this is a multiplied, 12 into 5, and this is 12 divided by 5, right? This is actually the division. 12 divided by 5 is actually, the quotient would be 2.4, so that is given. But if you perform modulus, this floor division, that is a double slash b, what happens is, in the quotient, this fractional part or the decimal part would be neglected. Only the integer part, that is 2, would be considered. So this is the answer you get by floor division. And a modulus b, this is just the remainder. So when you divide 12 by 5, then you get 2 as the remainder. Okay, so that was the example of arithmetic operators. So coming to the next one, there's also, for everything, whenever you're working on operators, you should remember the precedence, because when you have to evaluate an expression, you have to remember this. So what is operator precedence? Basically, if there is one expression where you have more than one operators, so in which way the operation should be conducted, so then you have to know the precedence, right? So this is a operator precedence. This one is the lowest and this is the highest. So addition and subtraction are having the lowest precedence. Next, after that, division, floor division, multiplication and modulus will come. After that, unary operators like plus x, basically it will be the increment, tilde x, that is the negation or the complement of x, that would be having the next priority or the precedence. Above that you have exponential, and then you have parenthesis. Okay, so this is the order of precedence, you have to remember this. Then operator associativity. So if an expression has two or more operators with the same precedence, for example here, if division and floor division both are there in your expression, then how it will be evaluated? So in this case, associativity comes into picture. It will either do the, so yeah, because both of them have the same precedence, division as well as floor division. So when the execution is done, either it can go by left to right associativity or right to left associativity. Okay, so all expressions are associated left to right normally, except the exponential. So basically what happens is, whenever you have such division and floor division in the expression, the precedence would be left to right by default. But of course, if you have exponential, then the precedence is right to left. So basically the rule that you have to remember is PEMDAS, where P stands for parenthesis, exponential, multiplication, division, addition and subtraction. So this is the order of precedence. This is the rule that you have to remember. Now let's evaluate an expression. Suppose they've given you the value as a is equal to 5, b is equal to 3, c is equal to 2, d equals 10 and e equals 3. And they have given an expression like this. So what would be the answer? This would be asked in the exam. So first substitute all the values in the expression like this. Now in order to calculate this, you have to remember this table. So according to this table, the highest precedence is naturally for the parenthesis, right? The highest precedence is parenthesis. So anything within the parenthesis will be executed first. So 12 floor division 10 means actually the answer of the quotient would be 1.2, but since it is floor division, 0.2 would be neglected, so that is why 1 would be taken. So the evaluation of 12 floor division 10 is 1. Now you get this expression. Now what is the order of precedence here? Now which is having the highest precedence here? See, exponential is actually having the highest precedence next. So that is nothing but, exponential means what? 3 double star 1, 3 double asterisk 1. So basically it means 3 to the power 1. It actually means 3 to the power 1, and 3 to the power 1 is nothing but 3. So that's why the answer becomes 5 plus 3 into 3. Now you have plus and multiplication, right? So how does it happen is, here multiplication will have the highest precedence. So that is why 3 into 3 is calculated. So 5 plus 9, so answer is 14. Okay, so this is the next expression. After substituting, now the same values are taken. After substituting, now first the values within the parenthesis has to be calculated. So 3 plus 12 is 15. Now you have asterisk, subtraction and slash. So which would have the highest precedence now? It would be for the both, right? Both asterisks as well as floor division will have the highest precedence. So what would the answer? You do left to right associativity. If we do left to right associativity, first 5 into 15 will be calculated. So 5 into 15 is 75. So now you have 75 minus 10 divided by 3. Now what would be the precedence? Now division will have the highest precedence, right? So it is 75 minus 10 divided by 3 is 3.333, like that. So the final answer that you get is this one. See, we can also try this in our system. Let me just copy these values. Go to the Jupyter notebook. Any questions like this you have, just go to your editor, cross check it. That's it. So I think the last one is E. Oh, okay. Okay, now let's execute. See, the value is 14, which is correct. Okay, so any questions, you first write on your notebook and then you can just execute in your editor to cross check the value. What you're getting is correct. See, we've got the same answer, 71.66667. Okay, so that would be the result. Okay, so now going to the next point. So that was about operator precedence and associativity. Now there's something called as compound assignment operators. Compound in the sense, instead of writing x is equal to x plus 1, y, you can write it as x plus equal to y. Instead of writing x is equal to x minus y, you can write it as x minus equal to y. So like that you have all the sequences. For this example, this is what you write. You write x plus equal to y. For subtraction, you write x minus equal to y. For multiplication, x star equal to y. Similarly, x divided equal to y. Floor division, first you write the operator, then you write the equivalent, equal sign. So just go to the notebook. Let's just try this. X is equal to, let's say, 10, y is equal to 5. Now x is equal to, let's say, x by y. Okay, and I'll execute this. So let me give a print for this. Okay, I should say x by y. So instead of saying that, what I can do is, so what I did here is, let's say x is equal to x divided by y, and here I'll give x. Okay, this is a value. So instead of saying like this, I'll put a comment for this. What I'll do is x slash equal to y. So this is a compound assignment operator. So instead of saying like this, I can write like this, and still I will get the same answer. It's just the same thing. So basically this is a compound assignment operator. Such operators are called as compound assignment operators. Now coming to the next operation, Boolean operation. Now three types of Boolean operators that Python supports are not, and or. Okay, so this is a logical truth table of the not operator. Not operator is unary, right? So if you give the 0 as the input, the output would be 1. If you give 1 as the input, the output would be 0. This is an AND operation. You will have two inputs, suppose, right? 0, 0, then the output is 0. So basically what happens in AND operation is, if any value in the input is 0, then the output is 0. Okay, even if one value in the input is 0, the output is 0. So that's why you see 0 and 0 is 0, 0, because here all the first three rows are having 0, the output is 0. Only in the last row, 1 and 1, all the values are 1, and that's why the output is 1. Now OR operation, what happens is, even if one condition is true in the sense 1, then the output will be 1. See, the first condition for the input 0, 0, output is 0. Here in all the other conditions, even if one condition is 1, the output would be 1. So these are the three logical operators. Now bool is used to indicate these. Empty is also used to indicate empty strings. So this is an illustration of the Boolean operations. So if you type this, if you just go to the editor and type this, what is print of not false? Not false is nothing but true. What is true and false? True is what? 1. 1 and 0 is 0, because even if one input is 0, output is 0. True or 0. True means 1. So even if one input is 1, the output would be 1. What is a Boolean value of 2274? Here it will be given as, since there is a value here, it will be given as true. What is a Boolean of 0? Since it's a 0, there is a 0, Boolean value of 0 is false. Okay, and you have to remember this order of precedence again. So suppose an expression is given to evaluate, you should remember the order of precedence. The OR is having the lowest precedence, next comes AND, next comes NOT. Lambda is anyway not there for you, but this is a sequence. Okay, remember this. If you are getting an expression where all these things are there, this is how you evaluate. OR has the lowest precedence, next AND, NOT has the highest precedence. Okay, you can remember in either way. Now coming to the third one, relational operators and Boolean expressions. See, logical expressions involves both relational and logical operators. Any expression that contains a comparison operator, remember, it will return a Boolean value. Okay, remember this. Any expression that contains a comparison operator, it will return a Boolean value. Example, see this statement, x greater than equal to 9, right? So it can have any two possibilities only. Either it can be true or it can be false. See, some of the comparison operators are x greater than y, x less than y, x greater than equal to, x less than equal to, s equals. Basically we are checking for the equal conditions, and not equals. Not equals is exclamatory mark equal to. So a condition for decision can be created using the relational operators as follows. So this is just a simple example where I am just saying a variable har is equal to 7, and I am saying meeting is equal to hars greater than 12. Now what is the value of har? 7. Is 7 greater than 12? No, right? It is not greater. Therefore the output would be false. It will return a Boolean value false. So if you are seeing the value of meeting, it will give a false. So again here, for all these comparison operators, you have to know the precedence, and it's very easy for you to remember. All the operators will have the same precedence. So it will just, if you want to evaluate this, just do the left to right associativity. Okay, they all have the same precedence. So this is just an example. If I say print of 7 less than 9, 7 is less than 9, yes, therefore the output is true. If I say print 7 equal to 9, double equals, that means it's checking for equality. Is it equal? No, so output is false. Print time equal to minute, are these two strings same? No, therefore it's giving the output false. So this was just a simple example of relational operators. Now coming to the next one, bitwise operators. Now these deal with binary bits of numbers. Okay, so here you will be seeing the numbers in their binary format. So these are the different types of binary operations that I will be showing you now. Bitwise OR, how do you do it? The symbol is like this. Okay, it's a pipe symbol. So this is, we call it as 6 bitwise OR. 7 that we are going to find. This is bitwise AND, this is bitwise XOR, this is bitwise complement, this is bitwise left shift, this is bitwise right shift. So there's one more thing, there is one more built-in function in Python which we call it as bin. Okay, now this function will convert the integer to its equivalent binary form, and whenever a number is represented in the binary form, how do you identify? It will have a prefix like this, 0 followed by a B. Okay, so see this example. If I want to, okay, let's go to the Jupyter notebook. So suppose I want to find the binary equivalent of 10. So how do you do? Just say binary bin 10. Okay, see the binary equivalent of 10 is actually 1010. It is prefixed with a 0b, indicating that this is a binary value and it's not a decimal number. Okay, let's find the binary equivalent of let's say 15. See, all the values are 1. Okay, so this is how, this is a built-in function in Python through which we can find a binary equivalent. Now let's start with the bitwise operations. This is bitwise AND. We will be seeing bitwise AND, bitwise OR, left shift, right shift, and XOR operations in today's session. Now coming to the bitwise AND, as I already said, if one of the number in the input, or even if one of the bit in the input is 0, the output would be 0. That is about AND, right? So how do you find? There's a problem here. Let's take find bitwise AND of 10 and 9. So how do you do it? Let's do it first on the paper, and then let's check whether the answer we are getting is correct or not on the program. Okay, let's first do it on the paper. So this is 10. I have to find the AND of 10 and 9. This is a decimal equivalent of 10, and this is a binary equivalent of 10, and this is a binary equivalent of 9. If suppose you do not know how to find the binary equivalent, of course you can do it through your Python program like this, but you should know how to do it. So I'll just show it to you how to find the binary equivalent of a decimal number. So let's say I have a number 10. I want to find the binary equivalent of 10. So how do you do it is, see, binary equivalents are actually, binary equivalents will have just two values, 0 and 1. Therefore the value of that is actually, it will be having 2 power of, okay, one second. So let's first discuss this, and then we'll come to that part later. So this is a bitwise. I will let you know how to do this because I need a pen for this. Okay, it's here. Okay, so until then it's ready, we will see. Okay, so this is a bitwise AND. So this is the AND operation of 10. So this is a binary equivalent of 10. This is a binary equivalent of 9. So even if one of them is 0, the output would be 0. So that's why all the outputs are 0. So what is the bitwise AND of 10 and 9? It is actually 0. So let's go and confirm this in the Jupyter notebook. We have to do bitwise AND of 10, what we have to do, bitwise AND of 10 and 9. Okay, so 10 and 9. So let's give a print statement for this. Okay. Oh, okay, I'm sorry. You have to give the symbol, not A and AND. Print of AND. See, what is the value I'm getting? 9, 8, right? So how is that? Because, okay, there is a mistake here. This is 9. This has to be 1. So therefore, this is 1. Okay. So coming back to this, so basically what is the value here? The value of this is 8, 4, 2, 1. So if you want to get 10, 8 plus 2. So that's why these two places are 1. When you get 9, it is 8, you have your 8, 4, 2, 1. You have to add 8 and 1. So that's why you're getting here 1001. So basically the answer is 1000, which is nothing but 8, which is correct. Now coming to bitwise OR. In the OR, even if one of the inputs is 1, the output is 1, right? So if you have to find the bitwise OR of 10 and 9. So this is 10. The value of 10 is 1010. Value of 9 is 0001. So what is the OR condition? Your final output you get 1011. This is nothing but what? It's nothing but 11. So bitwise OR, let's go to the notebook and check. Right, if I how to make OR, you just have to put this pipe symbol. See, you're getting the answer as 11. Now coming to the bitwise complement. Now this is something I need to tell. So bitwise complement operator is implemented using this tilde sign. Okay, now complement of 0 is 1, complement of 1 is 0. But when you are actually finding the complement of tilde 10, it is not straightforward. Basically here 1's complement is performed. This you have to remember. See, what is 10? Binary equivalent of 10, 1010. If I take just simply the complement of this, you will actually get 0101. That is not the answer. Okay, in Python, the bitwise complement operator is actually performed using the ones complement. So what is ones complement is? Just easy. First take the binary equivalent of 10. Binary equivalent of 10 is 1010. To that you add 1. So what would be the value you get? 1101. So what is 1011? It's nothing but 8421, that is 11, and then you have to write the minus sign. So this is the actual output that you get. Okay, so as I said, if you have okay, let's go to the Jupyter notebook to see this. If I want to find the tilde of or the negation of 10, see the output is 11. So how did I get this is it is not a direct complement, it is a ones complement. Take the binary equivalent of 10, to that you add 1. Whatever number you get, to that you add a minus sign. That's it. So suppose I have to find the binary equivalent of, let's say, 15. So what would be the actual number? 1. Binary equivalent is 1111. To that if I add 1, what happens? 1 plus 1 is 0. You will have a remainder. Then again 1 plus 1 is 0 here. Again 1 borrow. Carry, sorry, and then again you have a 0, and then again you have a 0, and then you will have a 1 here. So this is the value. So let's find it out. Tilde of 15. See, negation of 15 is minus 16. It's correct. See, because what is 6? This is nothing but 8421, and this place is 16, which is actually 16. Right? So 1 followed by 4 zeros. This is the binary equivalent of 16. Okay, so any doubt, just let me know in comment box. I will do this in detail, but just for you to I am doing this assuming that you know how to find the convert decimal number to binary numbers. I am doing this complete video assuming that you know the conversions. Okay, now coming to the bitwise left shift operator. Now left shift operator is basically shifts the bits to the left, right, depending upon the number of shifts you want to do. Suppose I want to shift 5 2 times by 2 bits. So first you write the binary equivalent of 5. So this is a binary equivalent of 5. See, this table I am showing the binary values. So this place is having a value of 2 power 0, which is 1. This is 2 power 1. This is 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, and this is 2 power 7. So if you want to represent 5 in binary number, you make this and this as 1, because if you add these two, 4 plus 1 is 5 and the rest of the things are 0. Now I'm doing left shift of this, so this is the binary equivalent of 5. If I left shift this by 2 and whichever places are empty, you have to fill it with 0. So if I left shift, what happens? I will get 0 0 here and it gets left shifted. So what is the binary equivalent of this? This place is 1, this place is 4. So 16 plus 4 is 20. So the final answer is 20. Let's check that in the Jupyter notebook. Okay, print 5 left shift 2. See, the answer is 20. Okay, so now coming to the right shift, it's just a similar, you just do the right shift in a similar way. See, this is 5. If you do right shift, what happens? These two actually you lose these two values and you'll be getting 0. The empty places will be filled with 0. So this is your final output. So basically the output is 1. Okay, so just a quick revision. This was bitwise AND, bitwise OR, bitwise complement operator, where one's complement is performed, bitwise left shift, bitwise right shift. So basically here also you have to remember the precedence. So the precedence is like this. The lowest precedence, OR has the lowest precedence. Above that you have XOR. Okay, and above that lowest precedence is OR, above that you have XOR, and shift, bitwise shift has the highest precedence. You have to remember this, because if expressions are given, you have to evaluate it for that reason. Okay, there's one more, that is bitwise XOR. I didn't tell you. So basically what happens in XOR is, in XOR truth table, if you know, if either it returns 1 if only one bit is 1. Okay, XOR table, truth table, it will return 1 if only one bit is 1. Okay, so that means if your input is 0 0, the output is 0. If the input is 1 1, the output is 0. If the input is 0 1 or 1 0, then the output is 1. So how to do XOR of 5 and 2? First you write the binary equivalent of 5 and 2. And what would be the output? 1x, as I said, even if one bit is 1, you get the output as 1. Okay, so here only one bit is 1, therefore output is 1. In this case also, in this place only one bit is 1, therefore the output is 1. In this place only one bit is 1, therefore output is 1. Here there are no ones, therefore output is 0. So this is nothing but what? 8 4 2 1. 4 plus 2 plus 1, that is 7. So 7 is the output. So let's check this on the Jupyter notebook. Print of, how do you do XOR? Just put this operator. We call it as a caret symbol. CARET. See. So print 5 XOR 2, the value is 7. That's what we got it from the presentation here. Okay, so today's class, that was a quick revision of the different types of operators. We saw the arithmetic operators, we saw the operator precedences, we saw Boolean operations, we saw the bitwise operators, we also saw relational operators. Go through all these examples. Any doubts, please let me know. I am ready to help you out. Okay, thank you.